Hey guys, and welcome back to another IBuddies video, and this is Chem SL Topic 3. So these are the 6 periodic trends that we need to know, and let us start with atomic radius. This increases down a group due to increasing number of shells. And decreases across a period, so I'll show the arrow going back to the start as that's the highest point, due to a stronger nuclear charge and the electrons being more closely attracted to the nucleus. These values can all be found in the IB data booklet. Now moving on to ionic radius. Ionic radius also increases down a group, similarly to more shells. And however, when going across the period, it becomes a lot more confusing. It tends to decrease up to period 4, and then at period 4, you have the largest, and then it decreases again going across. This may seem very confusing, and be aware that this point here is a lot bigger than this point here, and it's not a clear trend. This is due to the fact of the electron repulsion, as these all try to become full shells. Okay. What? Example. For example, you have sodium, we'll take it in this period, Na, and you could have in the period above it, fluorine. These both become like neon. And when fluorine becomes like neon, it gains an electron, and now has 8 in its outer shell, and 8 in its outer shell, 10 in total, with only 9 inside. And then that means there's more repulsion towards the outside, making the shell bigger than it was before, as it now has more electrons. For sodium, however, it loses its outer electron, and now it's exactly the same as neon, with a stronger charge, so it attracts the electrons closer towards it. So it would be smaller than fluorine. And now onto ionization. Ionization energy. Ionization energy is the energy required to kick off an electron, the first electron. This tends to, down a group, the energy decreases. So this is the highest point in a group. And this is because the further electron, the outer shell electron becomes a lot further from the nucleus. And due to shielding, there isn't much attraction towards the actual nucleus. And then similarly, across the period, the electron becomes a lot harder to remove as the shells begin to fill up. And as you would imagine, the noble gases on this side of the periodic table, such as neon, would have the larger, as it has a full outer electron shell. However, be aware that there are exceptions within it. This is due to stuff such as having a full p shell, a half p shell, or a full s shell, and so on along the whole periodic table. And now we can move on to electronegativity. This is based on the Pauling scale, and it could be considered very similar to electron affinity, which we'll move on to later. Electronegativity is how willing how much an electron is attracted to one of the atoms in a covalent bond. Electronegativity is the highest at fluorine, and increases across a period, and increases and decreases down the group. So the highest point would be at fluorine. This tends to be a very general trend, and there are very few exceptions, with the highest point at fluorine. And now moving on to electron affinity. Electron affinity, kind of similar, is how willing an electron is to accept another. How willing an atom is to accept another electron. This, the highest, as you would imagine, would be towards the halogens, and would increase across the period, and would would decrease down the group, as the nucleus doesn't attract the outside electron very strongly. Here there are a lot of exceptions due to spacing in the halogens, as chlorine has the highest electron affinity value, and there are many exceptions within the transition metals themselves. And then finally, melting point, which is the last trend we need to know. Melting points depending on which type of bonding occurs and where you are in the periodic table. At the metallic side, usually the melting point decreases down the group, with the highest one being up here. As due to in metallic bonding, the things that affect our melting point would be size of the atom and its charge. So for example, in a period, the highest one in period 3 would be aluminum, as it would become the smallest. Its ion would be the smallest and has the highest charge. On the other side of the periodic table, melting point increases down the group. This is due to the increasing London and increases across the period, due to the increasing London dispersion forces as atoms become bigger and bigger. And here, it decreases across the period. Be aware that all these values can be found in the IB data booklet. So if you ever are struggling on an exam, just check the data booklet. These trends do not need to be memorized, just be sure you know why they occur.